Now let's look at a few examples on how to write the sample spaces for combined events. We'll start with example number 2. Now, what are the possible outcomes when two coins are tossed? Now, a coin will have two sides, right? We have the tail and the head. So, letter T and H representing tail and heads respectively. So, what are the possible outcomes if we toss the two coins? Now, I prefer to use a table method, so it's easier for us to clearer, and more neat for us to see the possible outcome. Okay, so let's say this is the first coin. So first coin will have two sides, right? Okay, coins will always have two sides. So first coin will have tail and H, and second coin will also have tail and H. So the probability, first coin I might get tail. So if let's say first coin get tail, second coin might also get tail. TT. First coin might get tail, second coin might get head. First coin might get head, second coin might get tail. First coin might get head, second coin might get head as well. So these are the possible outcomes when we toss the two coins. So we can list down the sample space here. S is equal to TT, TH, HT, and HH. So the number of possible outcome, remember that the number of possible outcome can be calculated using the formula number of outcome of event A times with the number of outcome of event B. Okay, event A, which is the first coin, if we toss it, it will have two probability, so 2. And then second coin, if we toss it, it will also have two probability, so 2 times 2, 4. Same, the number of possible outcome for the two coins here, we have 1, 2, 3, 4. Next, let's look at the third example first. So 3 cards labeled with the letters X, Y, and Z are put into a box. 2 cards are drawn at random from the box one by one without replacement. What does it mean by without replacement? Without replacement means once I take out the first card, I do not put it back when I take out the second card. Okay, so for example, we have a box here containing 3 cards labeled with X, Y, Z. Okay, so let's say I randomly take out one card, so I might get X for my first card. Now, if I already take X as my first card, so inside the box now we only have left 2 cards, right? So without replacement means when I take out the second card, I do not put X back before I take out the second card. Okay, so this is mean without replacement. With replacement will mean that I put back the X, okay, before I take out the second card. Okay, so this will change the possible outcome of the results of the cards drawn later. Okay, so let's have a look. So we will also be using a table method here. So we will draw 2 cards, right? So first card, I will either get either X, Y, or Z. And then for my second card, I might also get X, Y, or Z. Now, if I already, let's say, first card I get X, second time I draw my card, I cannot get X again, right? Remember, without replacement. So this does not happen. So if let's say first card I got X, second card I might either get Y or Z. So first card X, second card Y, first card X, second card Z. If let's say I get my first card Y, so second card I might get either X or Z. So first card Y, second card X, then here we cannot have first card Y and second card Y. So this is not going to happen. First card Y, second card Z. And then first card Z. So if let's say I already get the card with the letter Z, so second card, I will not get letter Z. I will get either letter X or letter Y. So first card Z, second card X, or first card Z, second card Y. Okay. First and second card here does not happen. So this is our sample space or our number of possible outcomes. So we have XY, XZ, YX, YZ, ZX, and ZY. Okay, so the number of possible outcomes, we have 1, 2, 3, 4, 5, 6 possible outcomes. Okay, next, example 5, we have a fair dice is rolled and a fair coin is tossed simultaneously. Fair dice means it is a regular dice, the dice which has 6 sides. Okay, you know that one dice will have number 1, 2, 3, 4, 5 until 6. Okay, and a fair coin means both coins, the coins will have 2 different sides, which is a head and a tail. Now, what are the possible outcomes? Okay, if we roll the dice and toss the coin simultaneously. So we will list out the possible outcome using the table method as just now. So let's say I roll a dice. So this is my dice. So I might, if I roll a dice, I might get number 1, number 2, number 3, 4, 5, or 6, right? And my coin, I will either get a tail or a head. So let's say I roll a dice, so I might get 1, number 1, and then I toss a coin, so I might get a tail. I might also roll a dice and get number 1, and then I get a coin, a head. Okay, so 1 each. And then dice, I might get number 2 and a tail, or number 2 with a head, or number 3 with a tail, or number 3 with a head, or 4 with tail, or 4 with head, or 5 with tail, or 5 with head, or 6 with tail, and 6 with head. So altogether, this is my sample space. This is the number of possible outcomes that I will get. So 1 tail or 1 head, or I might get 2 tail or 2 head, okay, or 3 tail or 3 head, or 4 tail, 4 head, 5 tail, 5 head, 6 tail, or 6 head. And the number of sample space, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can also use a formula. So the number of sample space is equal to the number of possible outcome for the first event times with the number of possible outcome for the second event. So the first event is the number of possible outcome from the dice, which is I might get 6, right? So 6 possible outcome from the dice. And then the second event is the coin, so I might get 2 outcome from the coin. So 6 times 2 is also 12. So it's the same. It's the same number of possible outcome. Okay, so next is example 6. So Ali, Ben, Chong, and Daniel are assigned in pairs to take care of the class stall during canteen days. So we need to calculate or write the possible outcome for these events, right? Okay, so we will need 2 students, okay, since they are assigned in pairs. So we will need student number 1 and then student number 2. So student number 1, we can either have Ali or Ben or Chong or Daniel. And student number 2, we can also have Ali, Ben, Chong or Daniel. So if just now we have without replacement, so this is involving a person, right? So if let's say I already choose Ali as my student number 1, so I cannot possibly choose Ali again for my student number 2. So we cannot have the probability, we cannot have the possible outcome of Ali and Ali here. So this cannot happen. So same also, we cannot have Ben and Ben, or Chong and Chong, or Daniel and Daniel. So we may have a pair of Ali and Ben, or Ali and Chong, or Ali and Daniel, or Ben and Ali, or Ben and Chong, or Ben and Daniel. Okay, and then we can have Chong and Ali, and then Chong and Ben, and Chong and Daniel, and then Daniel and Ali, Daniel and Ben, and Daniel and Chong. Now, since this is involving a person, so the number of pairs, if we see a similar pairs, then we only need to write it once only. Okay, so for example, Ali and Ben and Ali. These are the same pairs, right? Same person, so we don't have to write it twice. Okay, same also, Chong and Ali and Chong. We don't have to write it twice. And then Daniel and Ali and Daniel, so the same thing. Okay, so we have Chong and Ben. So Ben and Chong is the same pair, right? Same person. So tak perlu tulis 2 kali. You don't have to write it twice. And then Daniel and Ben. So we have Ben and Daniel here. So no need. And then Daniel and Chong. Chong and Daniel. No need. Okay, so our sample space for our possible outcome for the pair to take care of the class stall. So we can pair Ali with Ben, or Ali with Chong, or Ali with Daniel, or Ben with Chong, or Ben with Daniel, or Chong with Daniel. And the number of our possible outcome here is 1, 2, 3, 4, 5, 6. So there is a few exercises inside your textbook, Self-Practice 9.1a, page 245. Please try out the questions first and we will discuss on the answers on the next lesson. Okay, so thank you everyone.